Hello students, so today we are going to learn about a very important and very interesting topic of the chemical bonding from class 11 chemical bonding. Okay, it is called Fajan rule. Okay, it is called Fajan's rule. What this rule explains? First we have to understand that. Okay, at the at the beginning of the study of chemical bonding, okay, we used to think that ionic bonds are different and covalent bonds are different. Ionic bonds are made up of completely donation of electron, like sodium will donate a electron Na plus and become Na plus to chlorine will take this electron to become Cl minus and will make NaCl and will make NaCl and will make what? NaCl, that is Na plus Cl minus. Okay, that is total electrostatic force of attraction. We used to think like this. Okay, in ionic bonds, in ionic bonds ionic bonds in ionic bonds we used to think like there is only electrostatic force of attraction between two oppositely opposite oppositely charged charged ions. Okay, so one positive ion and a negative ion, we used to think like this. And what is covalent? Covalent is like sharing of electron, like A will share one electron, B will share another electron, they will form like a and B bond. That is a sharing of electron. Sharing of electron, sharing of electron in where? Covalent bond. Fajan said something different. Okay, Fajan said something different. He said that no bond. He said no bond is 100% ionic or 100% covalent. That means in any ionic bond there is a covalent character, and in any covalent bond there is also some ionic character. Okay, this is very important to understand that how this happens. He said he explained like this. Okay, we are going to explain the rule, how we can say like this. Okay, let's consider a cation like this. Okay, and let's consider an anion like this, See, always from cation anion size will be bigger. Why? It has an electron cloud. The size will be little big. Now when an anion approaches a cation, okay, near to the cation, what happens? The electron cloud in the anion get distorted. What? Get distorted. The electron clouds gets distorted. Like it seems like that the anion is trying to share its electron cloud with the cation. This is very important to understand. It seems like that the anion is going to share its electron cloud with the cation. So this phenomena is called polarization. This phenomena is called polarization. Okay. And the ability of cation to distort the anion, is called sorry, is called polarizing power. And the extent to which the electron cloud of the anion will get distorted by the cation is called polarizability. Polarizability. Okay, this is very important to understand the words. So the polarization is the whole phenomena, and that cation, the power of the cation, the extent to which it can distort the electron cloud of the anion is called polarizing power, and the extent to which the electron cloud of the anion get distorted, it is known as polarizability. Okay, I think you have got it. Okay, so if you want to write a definition for polarization, what how you can write? Okay, we can write like this: the the attraction or distortion or distortion the attraction or distortion of electron cloud of anion towards cation towards cation towards cation is called polarization, is called polarization. Okay, so the attraction of or distortion of electron cloud of anion towards cation is called polarization. This is very important. Okay, now let's write the proper rule for the Fajan's rule. Okay, what is the rule? Okay, we are going to write the rule. It can come directly to your exam. Okay, we will write like small cation, bigger anion, small cation, bigger anion, and high charge on both, and high charge on both form better covalent bond or have greater covalent character in the bond. Okay, so what it says that there are two main factors that is depending, that is small or big, that means the size, and other is charge, that is charge. Okay, and there are two charge things, that is cation and anion. The rule said that for a better covalent bond or better covalent character in a bond, we need cation. Cation size must be small and anion size must be large. Okay, and charge in both the cases must be high. Okay, now let's discuss about what we are saying like this. Okay, just say, when we say the small cation must be small, what does it means? Let's first imagine a small pizza. Okay, it must be circle, sorry. Let's compare a small pizza to a large pizza. Let's say I told the person who is selling the pizza to divide it in 4 parts, both the small one and the bigger one, and he gave one oregano packet for each. Okay, now when I put oregano to the two pizzas, like the smaller one, the bigger one, which have more amount of oregano in each slice, where the taste will be strong. Obviously, in the smaller one, because the size is small and the oregano density will be high. Here the oregano density will be high, and here as the size increases of the pizza, the same packets of oregano, the same single packet of oregano will create lower density of oregano per pieces of or per slice of pizza. So it's like if you have the small size, your density, oregano density become high. Just like this, when you consider a cation which is smaller in size and a cation which is larger in size, the smaller one has larger charge density. Smaller cation has larger charge density, and the bigger cation has smaller charge density. It's very interesting. Okay, so the smaller cation has large charge density, and smaller cation and the bigger cation has smaller charge density. So if it has more charge density, the smaller will distort the electron cloud more, and the bigger will distort the electron cloud less. So the smaller cation will distort electron cloud of anion more. So it seems like the sharing of the electron cloud is more in case of smaller cation. So from here we can say the covalent character increases, and here when the cation is bigger, its distort electron cloud less. So covalent character must be less. The covalent character must be also very less. Thank you. Now what we can say? So we have understood that why for a good covalent character in a bond we need cation size small. Let's understand why the anion size must be large. See, if we take this same size of cation for both cases, and one big anion and one small anion for two cases, like this is case 1 and this is case 2. Okay, this is case 1 and case 2. See, it has more electron cloud. So the extent of distortion will be more. That means more distortion. Why more distortion? Why? Because in this anion, since there is more electron cloud, that is the last shell electron in the last shell electron here, the last shell electron is far away from the nucleus, and the Z effective is very less, so it can easily get distorted by the cation. So more distortions means covalent character increases. Now for come to this, here in the anion, from the nucleus the outer shell electron is not that far away, so the Z effective, that is effective nuclear charge, is high, so the distortion will be not that much. So distortion will be less. So we can say that covalent character in the bond will be less. So we have explained that why the anion size must be large. Now come to the charge, that is high and high. Both must have high charges. See, we have already explained the charge of the cation must be high by saying that it must have larger charge density, so it can polarize more. Okay, so it can polarize more. And the charge high in the anion, that means that is more electron cloud, more negative charge, that is more electron cloud. Okay, so its polarizability will be high. Polarizability will be high. Okay, so we have explained the whole Fajan rule for you. Okay, so let's see a very basic question from here, like if I gave you the compare polarizing power, polarizing power, okay, polarizing power, compare polarizing power between Li plus, Na plus, potassium plus, rubidium plus, cesium plus. See, this is the first group elements, all are the first group elements, like now so we know from down the group, we know that size increases, and we know for cation size must be small for greater polarizing power, the charge density will be high. Okay, so lithium has the smallest size, so it has the charge density highest, and cesium has the largest size, the charge density must be lowest. So when the charge density highest, the polarizing power must be high, and when the charge density is low, the polarizing power must be low. Okay, like this it can also happen, or it can also give you a question like this also. Polarizing power, you have to tell about the order of polarizing power between Li plus, Be2 plus and Al plus 3. We have already said that which are the highest charge. This is the highest charge that has the more polarizing power. So this, okay, the order will be like this. And if you talk about polarizability order, okay, polarizability order, we can say like example like F minus, Cl minus, Br minus, I minus. We know that if fluorine, chlorine, bromine, iodine, this is group number 17, where top to bottom size increases, and we know for anion the size must be high, the size must be large, so it can get polarized easily. So I minus has the largest size, and F minus has the smallest one, smallest size, so it can get polarized easily. So polarizability of I minus is the highest. Okay, so question can come like this, and we have to solve like this. Okay, So one more question I want to demonstrate, that if there is a question like compare covalent character, compare covalent character compare covalent character for BeCl2, MgCl2, CaCl2. Oh, sorry, I'm really sorry. CaCl2 and SrCl2 and BaCl2. See, here the anions are all same, chlorine, but the cations are different. Here the cation is Be2 plus, here is Mg plus 2, here is calcium plus 2, strontium plus 2, and barium plus 2. Okay, now we have to find which is more polarizing power, because more the polarizing power, the anion will get distorted more. Polarizing power is more, distortion is more, and we can say covalent character will also be more. So for polarizing power more, the cation must be small. So which cation is small? See, this is group number 2. Barium, magnesium, calcium, strontium and barium. Top to bottom size increases. So barium is the smallest one. So this has the most polarizing power. So it has the most covalent character. So barium chloride has most covalent character. Okay, this can come like this. And another question from covalent character, like sodium chloride, magnesium chloride and aluminum chloride, AlCl3. Okay, now see, all the cations are different and anions are same chlorine. So we don't have to think about the anion. Let's see, it is Na plus, it is Mg plus 2 and it is aluminum plus 3. Okay, now we can say a very important thing here. See, the charge, as the charge is increasing, the polarizing power increasing and polarization will be more. So we can say that covalent character will be more. So AlCl3 has the most covalent character here. Okay, now I am ending the lecture here. I hope you have understand the Fajan rule very clearly. Thank you.